The Reichert Ocular Response Analyzer utilizes a patented dynamic bidirectional applanation process to present the world's only direct measure of corneal biomechanical properties and a more accurate assessment of intraocular pressure. There are four key components to the applanation system of the Ocular Response Analyzer: a solenoid-driven air pump, an infrared light emitter, a light intensity detector, and a pressure transducer. At the start of the test sequence, the infrared light emitter directs a beam of light onto the cornea. The convex shape of the cornea causes the reflected light to be dispersed over a wide angle. The air pump now delivers a collimated stream of air directly onto the eye. As the cornea moves inwards towards applanation, the reflected light beam begins to converge, directing an increasing amount of light onto the detector. When applanation is achieved, the reflected light is nearly collimated and the detector registers a signal peak, causing the pressure transducer to record the applanation pressure. Following applanation, the air pulse continues to impinge upon the cornea, causing it to deflect into a state of slight concavity. The reflected infrared light once again becomes dispersed and the detector signal amplitude decreases. As the velocity of the air pulse declines towards zero, the cornea returns to its natural shape and once again passes through an applanated state. The reflected light again reaches maximum intensity and causes a signal peak at the detector, triggering the pressure transducer to record the applanation pressure a second time. The cornea completely returns to its normal configuration and the sequence is concluded. The entire measurement process takes approximately 20 milliseconds. The process results in a measurement signal similar to this one. The internal pressure transducer records the pressure required to flatten the cornea at the moment of each applanation event. One might expect that the pressure measured at the inward and outward applanation events would be the same. However, due to its viscous nature, the cornea resists the dynamic force of the air puff, resulting in a damping effect that manifests itself as a discrepancy between the applanation pressures. We refer to this phenomenon as corneal hysteresis. The ability to measure this effect provides us with the key to understanding the biomechanical properties of the cornea. This new ocular parameter differs from person to person and varies in the same person diurnally. It is not strongly correlated to any other known ocular parameter, including central corneal thickness, and has been shown to be essentially independent of pressure in normals. By now, nearly everyone recognizes that the current gold standard for measuring pressure, the Goldmann tonometer, has considerable flaws. The Goldmann is significantly affected by corneal properties because the device was designed to provide accurate measurements in eyes with average corneas. But we now know that many corneas vary more significantly from average than previously thought, and in more complex ways than simply thickness alone. Because the Ocular Response Analyzer is capable of measuring the biomechanical properties of the cornea, it is able to provide a pressure measurement that agrees with Goldmann-measured IOP on the average, but is uninfluenced by corneal effects. This new measurement of IOP, called IOP-CC, has essentially zero correlation with central corneal thickness and stays relatively constant post-LASIK. The Ocular Response Analyzer is convenient and easy for both the operator and the patient. The instrument sits neatly on any adjustable instrument stand and is controlled by a custom Windows-based program, providing graphical analysis of the measurement results. The software includes a comprehensive database that facilitates analysis of patient measurement data over time. This feature is invaluable for assessing treatment efficacy, disease progression, and post-surgery data comparison. And it's extremely simple to operate. Patient positioning is easy and comfortable, thanks to the left-right sliding headrest and the easy-to-find fixation target. Best of all, the ocular response analyzer utilizes a non-contact measurement methodology, so no anesthetic is required. Our patented hands-free automatic alignment system makes it easy for any member of your staff to perform the measurement. The instrument includes a convenient built-in ultrasound pachymeter, so operators can conduct multiple tests at the same workstation. The CCT data are captured and stored along with all of the other measurement results.